All right, welcome back to the course. So in this video, we're going to be talking about the results and the discussion. So, so I'm going to be showing you the result table, showing how each model performs in each performance evaluation comparison method, right? Okay, so it is actually here. So wait, this is line. Mm, okay, so it is actually here. Okay. So, I suppose we can actually copy this, right, to the, um, so, oh, okay, perhaps I'll just insert row below, and then I'll just copy that, right, so you can see it right here. And then the one with dimensionality reduction, right? Um, okay, so where is it? Okay, yeah, it's a bit slow. Okay, so this is the one. Then I'm gonna just put it right here. So here is the row below, and then yeah, okay. So this is how each model performs in each performance evaluation. So, and please note that this is actually sorted by accuracy, right? So the accuracy here is actually in descending order, but everything else is not very much sorted. And as you can see, you know, in terms of accuracy, random forest comes out on top, right? Okay, so um, so this is without dimensionality reduction, right? So we have all in all like this, and then yeah, with dimensionality reduction, it's actually like this. So like because it is sorted by accuracy, and both with and without dimensional error reduction, we can see that the first and second is actually random forest and linear discriminant analysis, respectively. Okay, right, and then the third one and below are the ones that differ. So perhaps we can take a look at the individual like scoring method. So like first we look at fitting time and scoring time. So technically here, the lower the better, because this means that this is actually sorted in descending manner, which means that the one on top actually performs really slowly, and that's not because technically, like in terms of time, you would want to have an algorithm that performs the the fastest, right? Essentially, So, but then I would say that with respect to other performance evaluation methods, I think this can be like of lower priority. So yeah, so as we can see here, because I think random forest and logistic regression are computationally intensive, right? So they're like among the highest one, especially random forest. Like the gap between random forest and other algorithms is very, it's a lot. So yeah, I can actually like, for example, right here, um, random forest takes more than twice the amount of time it takes for logistic regression to have its scoring process done, right? And even here, like in logistic regression, so random forest takes almost four times the amount of time logistic regression takes for it to have a model fitting process, right? So yeah, I would say that in a large data set, right? Um, uh, this may not be preferable, but that depends on like whether or not we prioritize performance to quality, right? So because like if we do have the computational resources, computational power, why would we risk like losing quality, right? So yeah. And then let's look at accuracy. So again, random forest comes out on top. Linear discriminant analysis, well, it comes out on top because like the one above here is actually sorted by accuracy. And of course, like here, it's going to be the same, right? And then for precision, we actually have linear discriminant analysis, right? Um, for everything else, usually random forest comes out on top. um like most of the time random forest comes out on top. Like for example, this comes out on top three times, like on accuracy, random for recall, and F1 score, right? And for AOROC, um, it comes out second place, right? So that's not bad at all. For precision, it comes out in second place as well. So I would say that, and of course, we can also consider like the second place for like consideration, like for example, the LDA. The LDA performs really good on precision and accuracy, and F1 score it actually places second, right? And then we have like quadratic discriminant analysis as well. Like it is actually worth mentioning as well, I suppose. And logistic regression, yeah, it comes out at third. In four methods, right? Accuracy, precision, recall, and F1 score. So those four are actually uh, worth considering, I suppose. Yeah, because they're among the highest performing, the best performing algorithms, right? Although one thing to take note is that this is actually without dimensionality reduction, and we shall see now how dimensionality reduction affects the results. So now, as you can see right here, so this is like the general display like of like how each model performs, right? And let's just jump into like the individual scoring measure, like the performance evaluation measure. Okay, so again, for the time it takes, the time consumed by the algorithms, the random forest comes out on top because it is computationally expensive, right? So the same way it works previously, it is actually in descending manner. So for time, the lower the better. But then for everything else, like for accuracy, precision, any other performance evaluation measure, you want it to be really high, right? So you pick the one on top, right? And then um, but then it's a matter of performance versus quality again. And as you can see right here, like for cutting time, random forest actually takes more than five times the amount it takes of the runner-up, like the logistic regression. And for scoring time, it is actually four times, actually four times higher, more or less, less than a bit less than, yeah, just almost like four times, right? Uh, as much as can end, right? As much as the time it takes for can end to do the scoring process, right? And this really tells us that despite the dimensionality reduction, yeah, when it is applied, it is still computationally expensive, and even more so, I suppose, like the multipliers here, like for example, previously for fitting time, it is only um, about four times, but now it is more than five times, right? And then for scoring time, um, with the dimensional day reduction, it is actually like a bit more than twice, but now it is actually almost four times, right? A bit more than three times, I suppose. Yeah, a bit more than three times. Yeah. So yeah, a bit more apparent, I suppose, in the data where we use dimensionality reduction, right? Okay, and then for other performance evaluation measure, they pretty much stay the same consistently. Like random forest comes out on top for everything except for precision. And then for precision, essentially LDA comes on top, and then random forest comes second. But the difference lies in AORC. If I recall correctly, um, I think quadratic discriminant analysis came out on top for the one without dimensionality reduction, and then uh, yeah, and then we have random forest and naive Bayes, and for this one we have random forest coming out on top. Okay, so I suppose let's so yeah, in general, a random forest like algorithm comes out on top for every square method except for precision, where it came out in second place. Although it does have its drawbacks, right? For with its fitting time and scoring time coming out on top, meaning it could potentially be more computationally expensive. And then let's have a side-by-side comparison to figure out whether or not dimensionality reduction has like dimensionality reduction affect the results, right? And we can like see. Okay, so for this one, it is actually quite similar. The scores are actually quite similar. See, just a bit of difference there, right? And still random forest and LDA comes out on top for accuracy. For precision, LDA comes out on top and random forest comes second, and only slight differences with the one without dimensionality reduction having a higher score, right? And uh, yeah, okay. So for this one, I think it's a bit inconsistent because like the for random forest accuracy, the one with dimensionality reduction actually produces higher accuracy result, but for the second one, the LDA, the one without dimensionality reduction actually produces higher results, right? So, and we can see right here that generally speaking, oh, I suppose we cannot generalize because like yeah, it is actually very inconsistent from one algorithm to another. But for this one, it is actually pretty much consistent. Like generally speaking, the one without dimensionality reduction produces higher precision, and then again, like LDA and random forest comes out on top. And then here is pretty much the same as well, or random forest comes out on top, and then QDA comes